Hey guys, and welcome to the second Robot C tutorial video that I'm going to be making. I think I'm going to start off today kind of where I left off when I realized that you could actually do the motor and sensor setup without having the robot connected, that all you needed was a file open. So I'm going to walk you through what we had for our setup this year so that you guys are able to use the robot and things how we have it now at the start of next year. So I'm going to walk you through each tab. This one, we're not going to do anything. Sensor management, not going to do anything. This is checked by default, so just make sure that it's checked. External controllers, you're going to want the standard matrix configuration. And then motors, now you get to name your motors. And so we didn't have anything on A, B, or C, but here we had the right wheel. So we're going to call this right wheel so that we can refer to it in our code as right wheel. This we're going to refer to left wheel. This was our flag, and this was our arm. And so we're not going to use any servos, we didn't have any hooked up, and we didn't have any sensors either. So one of the things that you're going to want to make sure, sorry as I open Word real quick just to get my notes, is that you're going to want to make sure that however you type it here is how you want it. So for example, I have the first letter of each word capitalized, and so that's sort of traditional. If you know anything about object-oriented programming, you know that objects are typically start with a lowercase letter. But I'm just going to use capital letters for the start of everything just for readability's sake so that we know that these are in fact the wheels and flag and arm so that they're motors we're going to be using. But make sure whatever you do here is how you use it. So for example, if I tried to refer to this as right wheel with a lowercase arm, I'm sorry, with a lowercase r in my code, it wouldn't work. So there's no real wrong way per se to code as long as you're following the syntax of the language, and we're going to get into a little bit of that here. But so, I mean, it's totally up to you if you wanted this capital, lowercase, whatever. It doesn't really matter. Just make sure that whatever you do, you're consistent. So now that we have all this set up, we're going to apply, and you can see that automatically gets generated up here. And so we're going to say OK. And now, if we wanted to refer to the flag, we would just refer to it as flag. Oops. And then that would know to fire the motor that's attached to the flag. So I'm going to kind of in this get into a little bit of the basics of coding, talk a little bit about code formatting and variables and things like that. So the first thing, if you look at this code, other than these definitions up here, is you'll see comments. And this right here is a comment. There's a couple different ways to do comments. You can do it either by the two slashes, and then everything else that you put on that line is commented. And so comments are for the user only. The compiler will ignore them, but they're to make sections of code easier to understand. So you can see here they use this comment here to describe the initialize robot method. So the one way is like they did with the two slashes, and so if you wanted to skip a line like they did, and you could do that. But another way to do comments, and this is for multiple line comments, is to do this slash with the asterisk. And then when you want to end it, you do the asterisk and the slash. And so anything in here is now automatically commented, as you can see. And so the green is comments. I believe you could change the color if you wanted, but by default comments are always green. So you can never comment something too much. You always want to put comments to describe what it is you're doing. So for here, I mean, even something simple as wait for start, they described exactly what that is. Wait for the beginning of the autonomous phase. You never can have too many comments as long as they're actually useful things that are describing what you're doing. And so when you're working on a project, especially when you're working with other members, so you have a team, it's big that you write comments because maybe you'll be working on something and you'll understand exactly how it works. But then the person you're working with will come over and be like, I don't understand this, but if there's comments, it makes it so much easier to understand. So now we're going to talk a little bit about variables. And there's many different kinds of variables, and all a variable is it's something that stores data. And so when you define a variable, you're going to have to know what kind of data that variable is going to store. And so that may sound a little confusing, but basically all that means is it going to be an integer, so a number that's a whole number, or is it going to be a number with a decimal, or is it going to be a true-false value? That's basically all you need to know. So we'll start, I talked about an integer, and so to define an integer, you would type int. And so that's the compiler now knows whatever variable is coming next is going to be an integer. It's impossible to define it to have decimals. It's only going to be whole numbers. And so once you have your int, you're then going to name your variable. So we're just going to call this variable int. And you can see that this is two words per se, variable and int, but I didn't use a space to separate them for many reasons. One, because variable is a term that's already taken, but two, because you can't refer to things with spaces. Everything has to be all one word. And so you start your variables with a lowercase letter, and then every word after starts with a capital letter. So if I wanted to define another int, and I called it wheel rotations, it would be like that, or wheel rotations number would be like that, with number being capitalized. So you have the type of variable it is, the name of the variable, and then you can do two things at this point. You can either put a semicolon, and the semicolon signifies the end of the line, so the compiler knows this line is done. And so this variable, variable int, the compiler knows it exists, but it doesn't have a value yet. So if you tried to use it, so if we said variable int plus equals 1, and so that's adding 1 to the variable int, and we tried to compile it, it's going to give us an error. Executable statement is not valid. And you can see here that it's giving us an error on this line, and that's because we never defined our variable int value. Although actually the real reason this is giving us an error is because it's not in the main block. So actually we'll throw this down here. So now if we did this, oddly enough, actually it doesn't give us an error, although it should. So that's actually something about Robot C that's interesting to note. I don't know if this gets auto-assigned to 0 if you don't define it, so that's something interesting. I didn't actually know that, so you learned something new. But typically what you do is when you create your variable, you assign it equal to a value. So in this case, we could say variable int equals 0, and so now this has a value of 0. So whenever we referred to this, unless we changed its value, it would be 0. And so if we did change it, then this would keep track of it, and so you would just refer to it as variable int. So that's how you would do an integer, but say you wanted to have something that's a decimal, like the number of times it's gone around, the wheel has gone around. Maybe it's gone around half a time, but with an int you wouldn't be able to do that. So there's a couple different ways to keep track of decimals. The two main ones are double and float. And by default, Robot C recognizes that double exists, but it converts everything to float anyways. But in other programming languages such as Java or C++ and things like that, double does indeed exist, and so the creators of Robot C recognize that, hey, if people are coming in with prior experience, they're going to know what double is. We'll just auto-convert that to a float. So you can use either double or float to define decimal variables. So if we said here, double variable double equals 0, we could just do that. We could set it equal to 0, or we could do 0.0 or 0.01. or 1.5. I mean, you get the idea. And with float, we could do variable float equals 1.2. And so now if we compiled this, we would see Robot C converted double to float, double not supported in Robot C. So it automatically said that this is now a float, but it does recognize that double is a decimal, and so it automatically converts it to a float. And so typically what you would do when you define your variables is you would put a comment above it to describe what it's doing. So, I don't know, this variable is an integer. And you would do this variable is automatically converted to a float value. Just things like that to comment so people know what it is that you're doing. And so you can name your variables whatever you want. As you can see here, I've named them things that are pseudo-relevant to what it is. I mean, they're relevant for the sake of this tutorial, but if you just called something variable int in your code, I mean, people wouldn't really know what that is. So if this was keeping track of inches moved, you would say int inches moved. And now this is a very clear definition of what this variable is keeping track of. It's keeping track of the inches that the robot has moved. And you would obviously put a comment up here to specify that it was the robot that was the thing moving, not, say, your arm or something like that. And like I said before, you typically start, or you always name your variables starting with a lowercase letter, and then you have the capital letters after that. You could, if you wanted, if you like, for whatever reason you absolutely needed to have it show up as two words. Like I said, you can't use a space, but you could use an underscore if you preferred. It's typical just to make them all one word with the capital letter signifying the start of another word for legibility's sake. And so, like I said, you always want to comment above your variables. Like, I can't stress this enough. You comment everything that you can. And so you can, like I also said, you can assign values later. Just make sure you do it. So like if this was inches moved, maybe down here we would say inches moved equals 0. And so now we would know what the value of this is, whereas up here it's kind of ambiguous. For example, in some languages, if you don't define the value, it is set to null, not 0. In this case, it may be 0, it may be null. Null is a thing. So this may get set to null, in which case you would get errors when you tried to actually work with your robot in that case. So always make sure you define a variable if you're going to use it. And so the last thing I want to talk about is the scope of a variable. And that may sound kind of complicated, but it's actually really easy. Variables can only be used within the hard brackets that they fall within. So if you defined a variable in here between these hard brackets, if we said int hello equals 0, you could not refer to hello down here. You couldn't say hello equals 1. That would not work. See right here, it says undefined variable hello. So hello, this particular version of hello anyways, is only applicable within these brackets. So we could define a different integer hello down here, int hello equals 1, and this works just fine. And while these may look like they're the same variable, they're actually two different variables even though they have the same name, because of the fact that they're within different brackets. So it's generally good programming practice to name all your variables something different, because otherwise you could get confused thinking that you have this hello here, you're setting it in the initialized robot, you're setting it to 0, and here you're setting it to 1. But in reality, this variable is now useless because you're not doing anything in here with the hello, and so this hello would be the one you'd refer if you tried to refer to it down here. If you said hello equals 2, this particular hello would now be equal to 2. This one would not. So if you had, for example, down here, if we did a different int hello equals 2, this hello would only be applicable within these brackets. So if we change the name of this to goodbye, int goodbye equals 2, now you could not refer to goodbye out here. Goodbye equals 3. If you tried to compile it, you'd see undefined variable goodbye. It gets confused. But what you could do is you could refer to hello within these set of brackets right here, because it's still within these brackets there. Okay? So hopefully that makes a little bit of sense, and you kind of have an idea for how to work with variables a little bit. We'll just do a quick recap. So like I said, there's basically three different kinds of variables. Oh, and I never got into Boolean variables, so let me do that real quick. I said that there were integers and doubles and floats, and doubles and floats are basically the same thing in Robot C. But the other thing, there's a Boolean, and what that is it can only hold true or false. So if you, for example, wanted to know if a motor was spinning, you could say Boolean, oops, it's bool in I'm sorry, in Robot C. I was thinking Java where it's Boolean, but it's bool in Robot C, is spinning equals false. And so Boolean can only be true. You could then say is spinning equals true, but you could not say like is spinning equals 10.6 or 3 or something like that. It just wouldn't work. So you only can name Booleans true or false. Alright, so I hope that this was somewhat useful, and thank you guys so much for watching. If you have any questions, please post them in the comments below. And yeah, just thank you guys. I'll see you in the next